Hi, I welcome you Simscape Fundamental section. So in this section, we are going to discuss in detail about what is the Simscape, how we can develop a electrical system in this Simscape model. Similarly, how we can develop a mechanical system in this particularly Simscape model, and how we can develop a electromechanical system to combine all the components like electrical as well as the mechanical components with the Simscape components. So here in as per our electric vehicle systems, so here we have to use mechanical systems as well as that electrical system. So the MATLAB is the only tool to give you such a kind of platform to develop all the components. And let us discuss one by one. So keep engaged with the entire class. And if you take in this electric vehicle system, so the DC motor, electric motor is going to give you the sufficient power to move your vehicle. So in that case, the motor is going to generate a power, mechanical power. So that mechanical power is going to feed to the electric vehicle system. So whenever the motor is started to rotate, from that point only the vehicle will start from its standstill position. So in that case, the motor and the gear systems. Actually, nowadays the electric vehicle comes up with a direct drive system as well as the gear system also. So let us check one by one. And again here on the gear system, with the gear we can increase the speed as well as we can reduce the speed also. So let us check one by one with the MATLAB example files. And so if you take if you want to develop a mechanical with the electrical system, so first you should know the physical variables for various domains. So what is the physical variables? So as we know that through and across variables. So the through and across variables nothing but, so if you take if you want to transfer any energy or power from one point to another point, then there is a two different parameters. So one is called across variable and then through variable. See, in the electrical domain, the power is the transfer component. So if you want to transfer the power from one point to another node, so in that case the voltage and then current flow between the two nodes, if you multiply these two variable, then we can get a power flow. So similarly, how you can understand and how you can measure the two variables. So if you connect a voltage sensor across the point across the two terminal, then we can measure the voltage. Similarly, if you connect a series sensor to measure the variable, so that is called the current sensor. So let us check one by one. And if you take this MATLAB example, see how we can develop this block and how we can understand this example. So here one DC source has been used. So this is DC source and then one load. So if you open the MATLAB, you just open the MATLAB and create a Simulink, create a new block. So let us name it sensors. So let us name it sensor physical variable L1. See here we are going to measure the voltage. So as per our presentations, the voltage source we need, and then load resistance is need, and two variables like we need a through variable and then across variable. So the through variable nothing but current. Across variable for the electric domain is the voltage. So let us name it. And so just to take a voltage source, either you can go you can select a component via library browser, or else just double click over the workspace and search voltage DC voltage source. DC voltage source, choose the second one. So this is the DC voltage source, and we need a resistor, RESI, resistor component, and we can give the value later. And so now we have to connect the component, and the sensor current sensor is going to connect between this two component. So like just to take a current sensor and connect like this. and take a voltage sensor. Connect this sensor like this. So now we can see the output, and similarly just to take a PS to Simulink converter, so that we can connect a scope block. Take a scope. Let us have a display model also, so that we can easily measure the variable here itself. This is the this is the current variable or through variable, and this is the voltage. So now we have to connect electrical reference ground. Just to take electrical reference ground. So without reference we cannot run the show. And similarly, since all the components comes under the Simscape block, so we have to add the header file. So just to search solver configuration. Just to search solver configuration. Connect this module to the anywhere of the. So now we are going to feed the value. So let us take 10 voltage, and resistance value is about 5 ohm. And so now let us check how the value will give. See here the voltage we have given 10 voltage. So it shows here 10 voltage. This is the across variable. So like that you have to connect your sensor, and this is the common principle for all the domains. And this is the current sensor. So we have connected to the series system, and by mentioning 5 ohm. So here V by R is equal to current. So in that case 10 by 5 is equal to 2 ampere. So like that we can measure. So this is the typical physical system we can easily model with MATLAB Simulink. So now we have understood what is the true variable and what is the across variable. So like this we have to develop all the electric domains, all the domains, to identify these variables. And let us come to this presentation. So this is current sensor and then voltage sensor. So if you connect the value, then we may get exact values. So the current and then voltage. So now similarly we have to develop a physical parameters or physical variables for the mechanical rotational domain also. So in the mechanical rotational domain, the same power flow can be multiplied with the angular velocity of the device, angular velocity of the system, and multiplied with the torque. See here the torque is a series variable, and then angular velocity is the across the variable. So if you take a yes. So if you develop this model, so we can easily understand this block with the following experiment, and I will tell you how you can model the mechanical rotational system. And similarly, this is the other variables. Already we have discussed the same topic in the previous session also. So in the electrical current and then voltage through component through variable and then across the variable. Similarly, the hydraulic flow rate and then pressure. Similarly, the rotational mechanical system and then translational mechanical system. So the torque and then angular speed for the rotational, and then translational mechanism force and then translation speed. Similarly, all the domain we have to calculate the power flow with the multiplication of these two variables. So now how we can understand how we can estimate the two variables. So actually in the sensor, by the sensor we can measure the how much amount of current and how much amount of voltage is available on the system. But before the current measurement and the voltage measurement, there is a formula that is called the Kirchhoff voltage law and then Kirchhoff current law. So by applying that to two variable, so we can measure the two systems. So if you take a Kirchhoff voltage current law, see here this is the two node. So generally the current law shows that incoming current is equal to outgoing current. So if you take this two this node and then a second node, so each and every node, so as per this circuit domain, this nodes the summation of current across that available at this node. Let us take it node 1 and then node 2. So the total current available on the node 1 and the total current of available on the node 2 is are equal. So how you can measure the variable? So summation of I1 to I4 equal to I6 I5 to I8. So all are equal, and then if you add this one, then we can name it as a current value, total value, current value 0. So let us check how we can measure this one. Similarly for the voltage law also. So here in the voltage Kirchhoff voltage law, see here, so this potential and then this potential are equal. Similarly, this potential available at this point and then this voltage available at this point is equal. And since it's a voltage source, see here this voltage source and summation of this two voltage source is equal to 0. Is equal, both voltage will be equal voltage. So since it's a voltage source and then these are all the components to draw the voltage from the source. So here suppose let us name it V input, and then let us name it V1 and then V2. So V in is equal to V1 plus V2. So like that we can understand the Kirchhoff voltage law. So this is generalized principle to understand the physical variables. So now let us draw the variable. See here, voltage source has been given, because actually for electrical system, source is the voltage source. So from this, if you connect a load, then we can draw a current from the source. So like that, the four resistance model has been modeled. So four resistance has been modeled, and from this four resistance, the summation of total current will be equal to 0. See here. Here I1 and then I2 is a 10 plus 15 ampere. Total ampere is the 15, and so this is called minus ampere. So this is the incoming current. So this is the incoming current to this node, particular node, and similarly these are all the outgoing current. So I1 plus I2 plus I3 plus I4. So I4 and then I3 is a minus current. So if you sum to this entire current, then we may get a 0 value. So at this node, so let us, I have a model, let us develop this one, and so just to take this four variables, four current sensors, four resistors. So let us name it I1, current sensor 1, and current sensor 2. Similarly, current sensor T and then resistance 4. So now we are going to connect all the resistance single node. So as per our calculations, this is the single node, we are getting the output. So this is the node. So now we have to measure the incoming current as well as outgoing current to the node. So let us name it to rotate the component. Just to use Control R to rotate the component. Like that, the current sensor, and then I1, I2, I3, I4. it flip the component so that really we can take a current from the I2 also, right? So I recommend you please practice this experiment to understand current and then voltage, the physical system. Not only physics, I mean not only electrical system, all the systems. And similarly, we have to measure the uh, return current also. Just to measure the current value. Similarly, for this one. Now we are going to estimate I3. What is the value of all the currents? So we have connected. So let us check how the value. So initially 2 ampere has been developed and drawn. So in the previous example. Now let us check. See here incoming current. So these are all the incoming current and then these are all the outgoing current. So to measure the exact polarity, just to reverse the polarity, you may get a output. So because we are going to calculate the current available on this particular node, so in that case you just rotate the component, and that is the sensor alone, we have to change it. Sensor alone, just reverse the polarity, so we can measure the sensor incoming current as well as that outgoing current according to this particular node. As per the Kirchhoff voltage law, so this value will be like a summation of all the currents. See here the incoming currents plus 1 and then plus 1 2 ampere and then minus 1 minus 1, so plus minus 2 is equal to 0. So this is the Kirchhoff current law. Similarly, we can draw the Kirchhoff voltage law also. So just if you want to change the current value, so you have to vary the current resistance value. Here I am using 5 ampere. So just if you increase the voltage source, instead of voltage source, just increase the current value, sorry, voltage value, you can get a variable current also. So in that, during that time also, all the current will be equal to 0. So this is a common principle for understanding the current. Incoming current is equal to outgoing current. Simply we can understand the concept. Similarly, we can go for the Kirchhoff voltage law. So in this Kirchhoff voltage law, so this is the source available. If you take a two variable, and see here the 50 voltage we have applied, and we have applied 50 voltage. So since these are all that loads, so summation of voltage available across that this voltage is also equal to the source voltage. But if you take a complete closed loop, so in that case voltage available on the entire loop will be is equal to 0. So here in this example, 50 voltage, 50 plus minus of 16.67 and plus minus of 33.33. So if you add this voltage, then you will get a 0 voltage. But across this across the each and individual load, then you will get a voltage. But if you take a complete loop, so that is the Kirchhoff voltage law. If you the summation of entire loop, the voltage will be is equal to 0. So let us try the same examples. Just to remove this component, take a two component, that's enough. Remove the component, connect two variables, and take a voltage sensor. So earlier we have used the current sensor, so now we are going to take a voltage sensor to verify the value. So just to take sources, and now we are going to measure this voltage. So see here, take a voltage source, connect one, let us name it V1, and this is V2, V3. So anywhere you can connect. So since all the voltages here, take a two different ground, so both the ground must be same one. So if you measure the voltage between these two ground, then that also will be the 0 1. This V3 and V2, and if you measure this voltage, this also will be a 0 1. Limit V4. Save the simulations. Try to run the simulation so you can easily understand what is the Kirchhoff voltage law. See here, the 50 voltage has been applied, is a source, and voltage across the source load 1 is at 25 voltage. Similarly, voltage across the load 2 is at 25 voltage. So now, if you want to calculate the voltage across the entire loop, so in that case, you just change the polarity, you will get a negative voltage. So see here, this is the positive and the negative. Similarly, this is the positive and the negative. You just connect a positive here and then connect negative here. So similarly for this one also, so just we are going to verify the loop voltage. Yes. So if you measure this one, so you can easily understand summation of all the voltage loop is equal to 0. 50 plus minus of 25 plus minus of 25. So if you equal to if you sum all the one, then you may get a 0 potential. Yes. So like this, we can easily understand the electrical system physical variable. So similarly, we have to develop a model for the mechanical rotational system. So in the mechanical rotational system, mechanical rotational system, first one is called, this is called torque source, and this is the gear system. And so this gear system is going to change your speed. So again, so here the parallel component at the angular velocity, if you measure the angular velocity, so we can estimate, because this velocity is only going to get a output. That is, this velocity is going to drive the vehicle, change the vehicle speed. Similarly, the torque. So the torque also needs to be added to the system. And so for that one, we have to take these components. Again, I'm going to open the MATLAB and create a new systems. Just remove all the one. And first we need to take a ideal torque source. So just search ideal torque source. So in the mechanical system, the torque source is the ideal torque source. Just to take ideal torque source. Here, so this is the source receivable point. So if you connect a gear system to this point, then we can change the source. We can get a angular velocity. For that one, just to take gear system, gearbox, simple gears, we take it. Just to take a gear, and after that we have to take a inertia model to, okay, this is the gearbox here. You take a simple gear. So again, one more gear system also there, so we can take that one. Open the library browser, take us, go to this the foundation library. Here the mechanical mechanisms. Take a gearbox. And take inertia. Take inertia, connect it here, and now we have to again we have to take a damper in a model. So the rotational damper needs to be added because the system must be in the smooth conditions. Just to take a rotational damper, connect as per this, and now we need a rotational reference end. Rotational reference. Reference. The model is about rotational reference. Mechanical rotational reference. Rotational. So now we have to take a we have to feed the value. So since actually this is all the Simscape block, so now we have to take a Simscape to Simulink to PS converter. We take a Simulink to PS converter. So which means that we are going to apply a value that is a Newton meter. So 1 Newton, I mean how much Newton meter. So whatever you are applying here, so that is a Newton meter will be applied to this system. And just to take a constant value to apply a Newton meter. So here I am going to keep one value, so which means that 1 Newton meter is going to apply to this system. So remaining things no need to do, and now we have to verify the variable. So here just to take a ideal rotational motion sensor. So just to take a rotational motion sensor. Yeah. So from this we can understand how much is the speed, angular velocity. And so now the C needs to be connected with this reference, and then W nothing but the sensor value, and then this is the axial nothing but see actually here no need to connect anywhere, just take a terminator. So here the PS terminator block will be there. PS terminator. Yeah, so the PS terminator will connect it. If it is required, then we can connect, else no need to connect actually. So if you leave it free, and that then I won't give you any issue. Now just to take this model, so rotate, use Control R. So you can rotate, you can keep it any size. And similarly, so the gearbox is going to increase the speed as well as the decrease the speed. Again, since it's a polarity based component, again take more block. So after the gearbox, we are going to measure the velocity. Take this again, or else just connect this. You can keep two references also, not an issue. And now we are going to take PS2, PS2 Simscape converter. PS2 Simulink converter, and see here to take a scope block. So this is the velocity before the gear and then velocity after the gear. Velocity after the gear. And similarly, in solver configuration, add solver configuration. Add solver configuration. Since it's all this comes under that Simscape block set, then we have to add it. So now let us check. You can reduce the speed. At least suppose if you connect S to O. So in that case, you keep it here. So the gearbox will reduce the speed of whatever you have given the value at here at 2 times. So remaining value, no need to do anything. So just simply try to run the value. So you can get a output. So this mechanic system needs to be connected with the DC motor system. Let us open the graph. Here, one is that high value and the another one is that second value. Reduced to exactly reduced by the 2 times. Now let us understand what is the input. Name it put speed, and this is the output speed. He blocks it, display, enable this whole enable this. Here the yellow line shows that input speed and then blue line shows that output speed. And still, if you want to change the value graph, want to get a clear idea, just change the scope parameter. You get a clear idea. Input speed, red color. Really output speed, and then it shows you the blue. So now you can easily understand. Suppose if you reverse the gear system, so since it's a polarity device, so if you reverse the one, what it will happen? Here now earlier the speed was about have reduced the speed. Now we are going to increase the speed. Here the input speed is the red one and then output speed is the blue color line. So now the speed has been doubled the time, and similarly you can keep it any value. So you keep it 1, then what so it's an ideal gear system has been used. Both are in the same one. So like that you can adjust the speed. So now the idea is we have to take a DC motor to drive the system. Since we have used the mechanical torque source to give the velocity. So now in our system, So the electrical component needs to be interfaced with this mechanical system to excite this system, to provide the excitation. Let us go for this. So now we are going to add the DC motor. So in the DC motor, so here in this DC motor again two system, one is called electrical system, similarly in the old mechanical system. So now the mechanical system has been developed. So this DC motor needs to be interfaced with this model, and we can identify how the system has been developed. Here like this, we are going to verify the value. So just to remove this one. Now we are going to add a DC motor block to this sensors, to this example. Just to take a DC motor, and now just to connect here, and so this is now we have to add the electrical block. So just to take a DC voltage source. In the EV system, we have to add the battery component. So for the understanding purpose, just to take a DC voltage source. Just to take a DC voltage source, the Simulink component. So just to take DC voltage source. So this needs to be added, and here you can feed the value whatever as per the motor dimensions. You can feed the value, and now we have to feed the parameters. So there are a variety of methods are there. You know the equivalent circuit parameter, you can feed it. Otherwise, you can go with as per the market standard ratings. 1750 is the no load speed, and then 1500 is the rated speed. And then mechanical power 10 e power 3, that is a 10 kilowatt, and then terminal voltage 10 wattage, 100 voltage. So since the electrical parts, so we have to add the electrical reference ground. Electrical reference. So now here also we can measure the through and then across variable. So let us check how the system can be developed. So let us check. The gear is a simple gear we have used to get a exact speed. Here both the speed has been same. Speed. The speed is going to increase now. So and after that, we have to connect this block to the vehicle body system. So already we have developed the electric vehicle free body diagram. If you connect this block to the vehicle body, then we can get a yeah. See here, the input speed is about 180 radian per second, and generally the speed will be in the radian per second. If you want to convert to the RPM, you have to add the multiplication factor 10 by pi. So if you add that one, then you may get a RPM value. So like this, we can develop the electromechanical systems. So from here, we have to add the free body diagram. So once if it's done, then we can finish our electric vehicle system. So this is the whole idea. Try to practice this one, and I will catch you in the next session. If you are interested in the internship, you will get a certificate by email. For that one, you will get an internship program. So here you can join the VP group, WhatsApp group, and you will get directly. You can get a support from me. How to how to do and how to develop your own vehicle and all. So that is the cost is only 590. The link is available in the description box, so you can get. And if you are interested, is 11th February 2023. 11th February 2023. Right? So you can join over there. If you have any doubt, you can ask me. I will try to give you the answers. And this is my WhatsApp number, so you can post your queries Here also I will give you, I am here to help you. See here, after joining in the internship, you can directly go to the our LMS website. So here you can get a TV bundle. So see here you will get a complete classes. Yeah. So you can download the MATLAB simulations. You can download all the presentations, everything. You can download the PPT. You can download the simulation files, everything. You can get it in the internship. Whereas for the YouTube sessions, you can post your queries. You just follow the live sessions, and you can practice on the live only. Yes. So all the sessions are available. If you are interested, you can go and join the internship. You can download it. All the notes are available to download. Thank you, participants. Thanks for valuable time. If you have any questions, you can post me. Just take my number. This is my WhatsApp number. So 98409744408. So if you have any queries about your research activity or your laboratory requirements, you can post your queries here. Thank you, participants. Thanks for valuable time. Thank you once again.